All right, civil engineering. No, you're not civil. Digital engineering. So what you are looking at today is desired output and what Ohm's law practice here. So we're going to look at desired output first here. We just have our basic 3-input truth table with our outputs high at, we got 4 different high outputs. So we need to make and do K-mapping is our best way to do it. So when we K-map, we start with not A, not B on the column, and then going across are the rows, and then not C and C. And then as you go down into the different rows there, you can only change one variable at a time. So it's not A, not B, not A, B, then A, not B. So then remember when you transfer that over from the truth table to the K-mapping apparatus there, you're making sure you skip the third and the fourth line moving. So what are we looking for? Pairs or bigger? We've got 2 sets of pairs there. What does that first set have in common? Not A, C. That's what stays the same for both of those. So that simplifies to not A, not C. Next one, what stays the same? A changes, B stays the same, C stays the same, so that is B and C. So what you're going to do then is just make the gate for it. Coming next week, we have found a live multisim. If you just Google live multisim, I'll get that out to you. We're going to mess around with that and do some counters and stuff. So all of you that love multisim in class, or you couldn't download it on your own machine, we're going to interactive one. We'll be able to do some things on there, build some counters, do some different stuff. So I'll walk you through that here next week. But right now we're still going to stick with pen and paper. So what do we have? Not A, not C into an AND gate. Then we got C and B into an AND gate. Both of those going into an OR gate. And that is when I would turn on. The 2 questions on there, just describing above, and then kind of come up with the situation. Just be creative. I'd like some type of creativity as you're sitting around here. So come up with, it's like a circuit that would work for. So then 2 different types of circuits you're looking at is a series circuit and a parallel circuit. Series circuit just is straight one. Parallel is all the different paths in parallel there. You're looking at Ohm's law, so V equals IR, so the total voltage equals total resistance times total current. If you're going to do calculations, try to keep it in base unit, unless you know better than that. Series circuit, total resistance is the sum of all the resistors. But for parallel circuit, it's different, so you got to do some thinking with the problems you're going to do here today. Total resistance on a parallel circuit is 1 over R1 plus 1 over R2 plus 1 over R3. So when they ask you to come up with the total resistance equal to something, you just got to do some work. My ask is that you have a minimum of 3 resistors in that question that you go ahead and do. Again, come up with any questions or anything else, please email me. Have a great day.